So welcome everyone to the first talk in this semester's Design++ seminar series. We're already in the 11th semester. It's unbelievable how this series has been going on for so long time, and we keep on finding great people to invite. So every semester we have 4 speakers. We aimed for a good mix between academia, established researchers, upcoming researchers, and industry, the same there. And as you see, I'll say a couple of words after the talk today about the next talk. But today we have, that slide is to show you that if you have missed a talk, you can find 11 semesters of Design++ seminar series talks on our YouTube channel, which is also the QR code leads to there. And today we have Pierre Chevremont from Itten Brechtbühl, head of AI at Itten Brechtbühl. And Pierre and I met at the Future of Construction Symposium in 24, end of 24. It was almost by chance. By the title, I joined a workshop that you organized with other great people at Itten Brechtbühl on AI-generated images and architecture. And I was really inspired by the views that we kind of started talking about AI and what it could do. And all this interesting take that you bring with you on technology and architecture is informed by very interesting also path, right? Pierre did a Master of Architecture at ETH and worked in well-known architecture companies, Caruso St. John, and now Itten Brechtbühl. But before that, studied cognitive science, which is the science, the study of mind and thinking and how we process and gain and deal with knowledge. Very interesting thing to have, which was followed by gigs in data visualization and data exchange policies at European level even. Coupled with an artistic practice that you recently started, and I think you will show a bit about your partnership with Nora and your art projects there. So I'm very much looking forward to hear your take again on can machines think architecture. And welcome, stage is yours. Pierre.
Thanks, Anton. Yes, thanks for the introduction and the kind words. So I'm very happy to be here. Always a pleasure to be on the Hunger Bear. First time I can present something here since my studies. So very happy and excited. So welcome to this presentation on the impact of artificial intelligence on architecture. We'll start with practical applications of this technology in the field. And then expand to the cultural impact of this technology and broader thoughts on its implications. I slightly changed the title as compared to what was being published, replacing the word AI by the word machines. I will explain a bit the reference behind during the talk. And I will start with the few words about the evolution of the digital technologies as applied to architecture. So architecture is one of the oldest disciplines there is, and it's been analog for most of its existence, like about anything else. In the case of architecture, until the advent of CAD, computer-aided design, which started to have an impact in the offices maybe in the 80s, even so the technology was invented before. Here you see a photograph of Ivan Sutherland with his program Sketchpad at MIT in the 60s. And I chose this picture because what you can see on screen is actually the direct reuse of a mode of representation that's pre-existed, the digital. These are the orthogonal projections from descriptive geometry as codified by Gaspard Monge at the end of the 18th century. So you can see top view, side view, maybe a section. And actually when BIM, building information modeling, came a bit later, a third dimension was added, and metadata to the model. But I would also here argue that BIM model, in the end, is not so different from a physical model in the sense that it represents building elements, but in not a very active way. And I would say that maybe the chance now with the advent of generative AI, that computer could use much more their generative power, like as was promised already by parametric and computational design, but that might be the full realization of that. And here I illustrate that with an example from a program called Hyper, which is actually not much developed anymore in that direction, but just as an illustration, I thought it was good because you see here quite directly a text to BIM workflow where you just write a prompt and a full-fledged BIM model gets generated live, which you can export afterwards to your favorite BIM program. So on the one hand, it's quite dramatic change in terms of human-computer interactions, like really a new interface paradigm. But maybe it goes even a bit deeper than that, because the use of this generative power of computer that made me think about Marvin Minsky, one of the key characters in the development of artificial intelligence, who said that basically until computer science appeared, classical mathematics was mainly having as a focus a much more frozen representation of like static states of the world, when computer science has really the power to describe processes. And our AutoCAD drawings, despite here the associative dimension lines are not very active, are not really doing much by themselves. And that's really actually what computer can do, is that they can carry out processes and synthesize form and even ultimately whole worlds. So here's just an example of cellular automata like John Conway's Game of Life, which produces a huge variety of forms. So here, what does it mean in practice now? Here you see the image that I use for the title of the talk, for the title slide of the talk. It's actually a building from ETH. It's the Machinen Lab, which has been originally built by one of the founders of the office I'm working with, Ethan Brechtbühl, like the architect of this building is called Otto Salvisberg, and he was one of the founders. The office has been existing for more than 100 years now. It's quite a large machine in itself, with more than 450 people and 7 locations. And yes, actually I thought it was nice as a title. There's a machine, there's architecture. So now, as regards AI at Ethan Brechtbühl, here is a diagram that represents a bit the framework in which we try to work. So the office has a range of domains in its core business. It's actually covering kind of all of the services that architects offer, starting with design and then planning and project management and construction management. Plus we have these communities like the AI community that I work for, and of course also a normal office structure with communications, office management, etc. And here it's really the idea that AI has the potential to be useful for everything. It's quite pervasive as a technology. And this through a series of modalities, images, geometry, text, analysis, which means numbers, and computer code. And then a lot of people ask if it will replace us, our office jobs. But actually, I think it's much more interesting to take a bit of a microscope and to look at tasks. And here I tried to list, just by myself, all the typical tasks an architect would do when doing a competition. And at that level, you can start talking really, like you can, it's a bit fictional here, but you can wonder for each task, can it be automated, to which extent, and with which tools, and have real debates on all of that when you look in detail. So that translates in our practice to a range of applications of AI. So from text-based application, writing even mundane things like meeting reports is quite a huge time saver. Then there is the whole knowledge management, calculating costs, making images, translating live events, and manipulating data in general, and producing analysis. So now in the next part of the talk, I will just start to review some of these things. But I will start maybe by a bit of a base about understanding architecture. If we scan all the capabilities of current AI models, that was one of the first tests I did that struck me. It was 2 years ago, by the time when ChatGPT got vision capabilities. And I thought that it would be interesting to have it take a kind of third year or second year architecture history or theory test. And I started to feed it this floor plan. And first, it gets right that actually it's an architectural floor plan. And when I framed it, then as an architecture historian, it could start identifying principles of symmetry or hierarchy. And then if you carry on with a photograph of the space, it could identify the raw concrete materiality, linked that as a historian to the movement of brutalism. Even notice the small human figure in the bottom that you might overlook, and thinking that it gives the picture a sense of scale. And then I went on, I asked for factual information, the decade in which the building was built, which he got right. Actually through reasoning or pretending to reason, that was based on the style, this estimate. And then when I asked, okay, but who built that? Then it said, no, sorry, I can't say. And then I was like, come on, why not? And then he said, okay, based on the style and everything, I think it's Louis Kahn, which is the right answer. It's the Exeter Library by Louis Kahn. And to finish with, I was like, bon, okay, let's try something more difficult. This view, actually, for someone who's not familiar with the building, maybe even an architect, it's maybe not self-evident immediately. This is the cross-bracing in the central space, and it nailed it. It was like, yeah, this is the cross-bracing structure, and the play of light, the robust materials. This is all very much in line with Louis Kahn's themes in his work. So at that point, I was like, okay, the exam is passed. There might be partly an illusion linked to that, as with also bar exams for lawyers, but I found it interesting. So then, that's not all you need when you work as an architect. You need actually many other capabilities. You work with floor plans, you calculate costs, you assess performance. And here, I will not dig deep into this topic, but show just a few things. The plans, it's almost an ironic example. It was what DALL-E 3 was capable of doing. It's very shallow, looks like a plan. If you ask to do the plan of an office building, the ground floor with the lobby, etc., you get some alien annotations. You get a service core in front of the main entrance, outside. So it's not really a plan. So it's a bit funny, but already 1.5 years later, with ChatGPT 4.0, I thought it got more convincing. This is not very impressive yet, but it is more realistic, and the argumentation in text is actually quite good. Maybe this example is very short, but in general, it can start to think about how to place places on which floor in a pretty convincing way. And this is one step. And if you do this step again, and I think it's already been done with Nano Banana, I have no example here, and if you do it even one more time, then you start to land in a territory where you might think that this general purpose technology of LLM might be one corner where intelligence is coming into this dream of architects to have a floor plan auto-completion. So cost, key value is an app that we're using at the office. It's not generative AI, it's actually decision trees like older machine learning techniques, but it's database. They claim to have 100,000 buildings in the database, and you just fill in a few forms and get a rough cost estimate that's actually usable. So that's interesting. And then another thing is for sustainability assessments, surrogate models, that you actually have a huge gain of speed as compared to physics-based model, which is actually a big deal for designers. If you can get almost real-time feedback, then you get a direct intuition of the effect of the changes on the phenomenon, of the changes on your design, on the phenomenon that you're considering, and that provides you a new intuitive way of dealing with this aspect. So now I will dig a bit deeper into images with this idea of thinking in images, if AI can think in images. And here I like to confront two quotes from two different disciplines, one of them being computer science, with one of the founding fathers of the discipline, Alan Turing, who famously asked, when he introduced his test in 1950, actually in a philosophy magazine, writing a paper called Computing Machinery and Intelligence in the Mind. And I propose to confront this question asked by Turing to the definition of design provided by Zumthor in Thinking Architecture at the end of the last century, that producing inner images is a part of thinking, associative, wild, free, order, systematic thinking in images, in architectural, spatial, colorful, and sensuous picture, making this his definition of design, actually. So can now machines think in images, and especially think architecture in images? So here again, a short historical review, starting with Google Deep Dream, developed with Alexander Morvintsev, who's also here in Zurich. And here it was the idea of using in reverse convolutional neural network designed and trained to detect faces and other patterns in images, and to have it produce images in a kind of pareidolia, I don't know if I pronounced that right, which is basically the phenomenon of seeing faces in the clouds. And because this reversal procedure is ambiguous, because it utilizes a one-to-many mapping process, you see many occurrences of the same object in one image, it results in this very distinctive psychedelic appearance, which made the buzz at the time. But also, 1 decade ago, at the same time, there were like uses of deep learning models to produce much more classical-looking images, like this project here called the Next Rembrandt, where Rembrandt experts and data scientists gathered and fed the model with, I think it's 346 examples of Rembrandt paintings, generated this one. As a result of the training, after that, they printed it with layers, kind of thick paint 3D printing. And you get a result that, at least for a non-expert, might really be taken for an exposable painting of Rembrandt. And all of that started to have impact on the art market. Here an example, French collective, Obvious, sold at an auction at Christie's this work, this portrait, for $432,000. And what I find interesting is that they, instead of using their name as the signature, they have actually the objective function that was used during the training of the generative adversarial networks that were used to produce this image. And all of that became, a bit later, like a couple of years ago, widely available. It's next generation of models, diffusion models, flow matching models. And here, maybe one big moment was Midjourney as regards architects using it in practice. And that induces a bit new ways to work. Like now, you can work using metaphors, for example. Here, it's a public living room. This is a metaphor that was in the brief of a competition for a city hall we did. And immediately out of these words, you can produce a visualization of a space that has a bit this domestic characteristic and maybe this public dimension. But then someone might come to you and say, okay, I don't think that a public living hall is that at home, and have a bit of a more conservative stance and say, no, actually, a public living room, this is what Erik Gunnar Asplund did at Göteborg. This is just a photograph here of that. And you can say, well, this does not have to be mutually exclusive. Like, actually, you can mix together these two views, blending these images using AI models, and like not proceeding in pixel space like you would do in Photoshop, but maybe rather in the clip embedding space, or there are different ways to do that. And then, as a result, when you combine these images together, when you hybridize them, you do it at a series of different levels. Like, you start to see here the different architectural elements from both images, like the wooden parapet, the columns, the also materiality, the reflective floor of the other one, and the quality of light. That is all is addressed. And one of the ideas I find fascinating using these systems is the one of levels of meaning. This is something that was already present before diffusion models in convolutional neural networks. We see a work from 2013 from scientists at NYU who had a method to visualize the feature detectors that emerge in the layers of a deep neural network, and also the patches of corresponding images they match with. And here, it's a bit like actually it is in the visual system, in the brain, that the first layer of the processing detects orientations and edges. Then you start to combine that, create edge conjunctions, and shapes start to appear, and then textures, and then object parts, and then entire objects. And if you propose to go even a bit further, actually you land into the realm of art history. And here it's one of maybe the most famous interpretation framework from art history, Erwin Panofsky's level of interpretation. And first you have the natural subject matter, the level of the pure form. In the case of this painting, it would be just 13 men sitting at the table. And then you can go up to the iconography. For someone who possesses the cultural codes, you would know it's the Last Supper, a scene from the Bible. It has conventional meaning. And then you can go even further up to deeper levels of intrinsic meaning, asking why Leonardo da Vinci chose to represent the Last Supper in this and that way, etc. And it's interesting with AI that you can climb this ladder all the way up. Actually, there's also work from last year from EPFL that this kind of hierarchical and compositional features that also appears in diffusion models. And then with the models, you can also paint with words. You really have this capacity of translating back and forth between these modalities, and I find that extremely interesting. That means maybe a good writer or poet might become the next great architect. And here is an animation to illustrate that by Stanislas Chailloux, who wrote also a book on artificial intelligence in architecture. And here it's the idea that if you recombine words, elements of meanings, you can directly produce representations of architecture that articulate these notions. So we're really in the realms of semantics, and he thought maybe now we're shifting from parametricism to semanticism. But actually, it's also a theme that has been pervading completely the history of architecture, this relationship between meanings, narratives, and the build form. Like if you take, for an example among many, the stories in metal and colored glass of Gothic architecture. Then there is also the dimension of time, and this AI, as also Mario Carpo argues, they are able to serve as time machines. And this is a topic we explored when I met you, Anton, in Mendrisio. Did a workshop taking as a case study the main building of the architecture school of Mendrisio, the Palazzo Turconi. And we first photographed it a lot, reconstructed in 3D, assembled the corpus, of archival material, lots of photographs, text about the history of the building, and gave to the participant the tasks to either bring it to the future or possible futures, like with different scenarios, like fabrication hall, a bit like here downstairs, or actually here, a similar idea as visualized by you, Anton, and Alessandro, of a robot that might build itself or unbuild itself, who knows. And that's also like reversing this arrow of time is something we were interested in, not only the future, but the past. And here it's just a photograph of one of the teaching spaces now. And we transfer it to the past. The building used to be a hospital in its original use. And I found it quite funny that the working tables, drawing tables of the students like become, again, beds for patients, maybe not so comfortable. And voilà. And you can do things that you would really have difficulties doing with any other digital image making technique, like stripping down the wall plaster, rendering of the walls, getting back to the raw nature of the building. So that much for pixels. It's also actually interesting to go beyond. And this is, with very quick tests, things we started to explore at the office. This time saying to the model, you can use any, Gemini, ChatGPT, Claude, whatever is your favorite one, and frame it as an expert at the intersection of different fields, so architecture, history, 3D modeling, parametric design, and then ask it to do actually a palazzo generator, 3D, parametric, and the model will do that. Like kind of first try. It will first write a little master thesis on the topic, digging on obscure sites about the Renaissance in Florence and the Palazzi, write Python code, and then make this generator that actually, after a few loops that you do yourself, you can get quite detailed. Still a bit buggy, and that's really the interesting question. What are really the geometric capabilities of LLMs at this moment, considering the fact that they also all include vision now? And this is something that we want to explore further at the next Future of Construction, starting to prepare a workshop with this example of Bernard Tschumi. I also saw actually just today that he will be soon here for an interview or an exchange. And we thought about this example because it has a well-defined set of rules. Like this is the design logic that Tschumi devised for his pavilions in the Parc de la Villette in Paris, and he built like, I think, 25 of them. And this is relatively simple. This has a degree of expressiveness and openness that is interesting. And for us, it's a bit like a model organism in biology, or like a Drosophila or something, that you can take this simple example and see how much AI is able to respect the rules, and also how creative it gets within the framework of the rules. So that's something I try to explore. Voilà, so that was for architectural practice in a professional setting. And then with Nora, who's here, we've actually started 2 years ago more free artistic practice, which we named Constructed Visions. And here is first a video from an artist that made this installation 15 years ago, Rune Peterson. I don't know, it's a bit dark. It was a triptych, 3 videos. The one in the center is pretty banal. At first glance, it's just what a person walking through a park is. With also, you see the red dot of the eye tracking. And on the right, you see actually what the retina of the person would see at any given point in time. Because like on the retina, there is just the central part, the fovea, which is really precisely sensitive. And then if you take the measurement of the eye tracking and you project that on the to the space of this video, like you can see which patch of the image is seen at any given point of time. And then that shows, I think, quite well that vision, and all of perception for that matter, is actually constructed. Like this a seemingly stable percept of the exterior world is something that is computed by the brain, hallucinated even if you wish. And we had our first exhibition and installation last year with this art project. The exhibition that was at Loop, which is the gallery of Pool architects here in Zurich. It was a double exhibition. We were in dialogue with photographs made actually with an analog camera from Ralph Blettler, who's also an architect and has been carrying his camera for maybe more than 20 years, photographing familiar scenes. And for us, that was really interesting to have this confrontation to photography, because we see the work as a form of photography, but not of the normal world, but of other possible worlds as they exist in the latent spaces of the models. But it feels almost like you would press the button of a camera when you render one of these images, and that you can explore that. And that's what we're interested in. So it all looks familiar, but with a shift. Here you have quite rich realistic details, but also superimpositions that introduce ambiguity between the real and the represented. Here maybe it's not really marble, it's a painting, etc. There's also real painting. Or even contradictions and physical impossibilities. Like, for example, this light situation is not really possible here. Or here, this might be a glass box at first glance, maybe like some work by Dan Graham. It might be a negative space. But we always try to blur the lines to introduce more degrees of complexity that further inspection reveals, while also always proceeding from memories. This might be in Switzerland, this might be in France. This has this familiar component to it. Also, zooming in a bit, we're very interested in materiality, in realistic representation or hyper-realistic representation of materials. But also in the moments where it switches to something else and becomes, as I said a bit at the beginning, slightly otherworldly. And then that means that the moment where you bring these digital images into the physical world was particularly interesting for us. We used a technique called C-print, chromogenic prints, which was the same that the photographer in front of us was using, except that his source was analog, and ours, it's printed not with light through a film, but with a laser, but on the same photosensitive paper. And then there is an interplay between here. It's almost as if the real light would shine on the work. So we're interested in that. Here's another example. And if we go back to the digital form, like all these works, we did actually at high resolution. Like some images were even, I don't know, 30,000 pixels wide or something. Exaggerated a bit, because this introduced, again, layers of meaning. Some form of fractality, but not really self-similar. Like here, the fine detail contradicts the large scale. It was kind of glassy and reflective as a whole, but in detail, it's much rougher. It's like branches, it's like an engraving or something. And you can even go further. So the last video, this was what we had in reality, and this is like digitally, you can zoom in even more. So this has nothing to do with physics anymore. You will never see the atoms, but it always invents some things further and further. Like the IMS video, but in a strange digital space that loops back to something at the level of visual perception always. So again, of this topic of the relationship between the digital and the physical space, here a quite direct superimposition. It was at Hochparterre with Ethan Brechbuhl helping us for the projection technique. We use this display window, like they have a series now of installations. Every second month it changes. And we thought it's very interesting as a screen. And we photographed the space, as you see it through the window, and superimposed it with control nets, reusing the main spatial structure, the lines that represent the space, and having it go over from the real into the digital. So voilà. I guess it's quite long, the video, but I have to watch all of it. Then in the 5 last minutes, I just have a bit of concluding thoughts. Okay. Still expanding, digging deeper into the idea of the relationships between the digital reality and the physical reality. And here I was thinking about the ideas of Christopher Alexander. For example, the idea of living structures, which for him concretely are towns, streets, buildings, rooms, gardens, and all kinds of places which are themselves alive. And he precises a bit more formally what he means. This is walls made of many interrelated centers that support and intensify each other so that they feel coherent, alive, and life-giving. Here you see a villa that he did, which tries to implement these principles. And for me, it relates to some idea also from psychology in the second half of the century. It echoes, for example, research from James Gibson, the ecological approach to visual perception, which started a branch of cognitive science that had a much more embodied approach, where agents, like perceiving agents, are actually embedded in the world. We perceive through our bodies, but we are always immersed in an environment that actually provides already structured information. We pick up meaningful information from the environment itself as we move through it. That means that perception is actually always action-oriented, and one central idea is this idea of affordances, which are action possibilities offered to an agent, which might be a human, an animal, or a machine now, by the environment according to its capabilities. So that concretely also in architectural terms, like we perceive stairs as stair climbers. Like immediately in our perception, we have present in mind the information that we can actually go up these stairs if it would be 10 times bigger, and we would not have the possibility of interaction with our body in the same way. That would structure out our perception completely differently. And that kind of flips the script of the constructivist approach I showed before, saying that the brain reconstructs the whole scene with this video of the walk in the park. And here it's more the opposite idea that visual systems have evolved to pick up information directly without the need for complex internal processing all the way through, because it's already present in the environment. And now you have also views that synthesize both approaches. But what's interesting maybe right now, considering AI, is that this kind of active embodied approach, exploring approach, is reflected in contemporary artificial intelligence benchmarks, like the third iteration of the ARC AGI benchmark, artificial general intelligence benchmark, here interactive for interactive reasoning. And the task here, like the two first iterations, it was more like logical visual puzzles. But this one requires the agent to explore, learn, plan, adapt, and discover the rules by itself, and also to do that efficiently in a kind of video game where you don't have infinite energy and you die at some point if you try a brute force approach. So these kind of things are getting a very important measure of intelligence, and I think that's great for architects, because if one think of Christopher Alexander, of this affordance concept that might be useful for us designing spaces which are made for people to live in. And it's a very big thing right at the moment in AI. I've just seen also that Autodesk invested into this type of approaches, not into Google, into World Labs. But this idea of world models, which are neural networks that understand the dynamic of the real world, including physics, spatial properties. Here you have Google Genie running. And yeah, what's interesting is that these are immersive environments. You can act in them. You can leave traces that persist. And you have both agents that are also able to live and act in these things, AI video game players, but also AI environment generators that conversely synthesize the whole world. And to conclude, I would say that this sheds a new, very interesting light on something that Christopher Alexander was foreseeing already 30 years ago. As you can notice also from his nice outfit, it was in the end of the 90s. He was actually at an object UPSLA. I don't remember in detail, but this is object-oriented. He was presenting in front of programmers and computer scientists, software engineers. And he was basically saying that while traditional, it's not an exact quote, but that while traditional designers have quite static methods, which brings us back a bit to this point of Marvin Minsky with the staticity at the beginning, actually it's computer scientists, software engineers that have unique procedural and generative tools that can really much help to build these living structures. He talks about a vivid, vital, real world. So I guess all of that, like these questions from computer science, from cognitive science, becoming very much, they're now really much in the spotlight through this tremendous development of generative AI that almost outlines a kind of very vast research program, actually many possible lines of academic inquiry at the intersection of all these different threads of architectural practice, theory, art history, computer science, and cognitive science. So that's it.
So thanks for the very interesting, insightful talk. I think we have time for questions, and whoever wants to start, I have one ready, but I already see someone there.
Hello, thank you for the insightful presentation. I had a question with, it's a bit both questions, but I think they are linked. There is this thing with AI that it can be quite replicate some old patterns and especially stereotypes. We can see it in the hospital when you have to show it. It's mostly women in the screen. My question, and it's also linked to architecture, because then maybe it will only get the most traditional or the most well-known patterns. How do you think we can avoid this with this type of tools? And what are the guidelines to still be innovative, not reusing what's already done? Yeah, thanks.
Right. Yes, thanks a lot for the question. It's a very important point. I had a couple of other slides that I dropped at the time about the fact that all of this is based on data sets, and also these data sets are processed. So in the case of LLM, it's particularly evident there. There's the second phase of the training of the model, where human preferences are super clearly reflected, because real people choose between examples according to their preference and according to instructions given by engineers that reflect the preferences of these engineers or the companies they are working with. So prejudice, bias is completely built in, and always. But also, there is nothing really as a neutral piece of text, or maybe the formulation of theorem in math or whatever. But in general, text not neutral, images are not neutral, are not innocent. And so you have it always. And how do you deal with that? But the first point is to be aware, especially if you use like pre-made models, which is now at frontier level, this is what we do anyway, because there are just a few of them produced by large companies. In my own tests and work, what I saw is as soon as you bring in a bit of your content, like a well-crafted prompt, a few reference images as an input, you start to really be able to drive the model into some zone. So you might leave the cliches quite fast. And I think it's nice to work a bit against the model to bring it out of its comfort zone. And I think it's quite reflective exercise that brings you yourself out yours. You know, the model pulls you, and this is this push and pull. And I think even without going into more advanced fine-tuning techniques that are more computationally intensive, even with out-of-the-box models, you can explore regions. Because what they do is always a synthesis, like it's based on something, but I guess there is kind of genuine creativity in the way they reassemble patterns, like in the sense that they might link together two things that no human has ever linked in history, because there are so many concepts and the combinatorics explode, of course, and then there are so many things you can associate together and produce new insights.
I might not be able to ask my question.
Thank you so much for your nice presentation. It's quite inspiring. One of the core questions that I have in mind when you see your presentation is, what is actually your position of what architecture is? So, how AI think about architecture, but what architecture that AI think about? Is it about the image, the representation, or the space, or the materiality? And I mean, for us, like, also, what is next? What kind of architecture that AI can possibly think of beyond images? And you mentioned about word models. Like, I mean, it's maybe interesting for computer scientist point of view. Okay, what AI that actually serve architecture point of view?
Yes, thanks for the questions. It's broad and it's pretty fascinating. But one thing is that first, it allows you to pull in extremely many, from these levels of meaning, right? Extremely many dimensions that you can work with. You know, you can really discuss, like, input into the model some thoughts that you have, some questions that you ask yourself at any level, and they maybe do not have to do directly with space and physical constructions and materiality, but the model is able to translate to that. And so you can consciously explore all of that, which of course is, I'm very interested to answer maybe broadly in the fact that we humans and architects trained maybe with a background, some experience, we use that because it triggers us. You know, it gives us new thoughts and it enables us quite fast, iteratively to explore realms. And for me, it remains maybe to be seen. I'm also very excited to see what the AI architecture, once it's mature, also really much in the sense once people have really found the right ways to adopt that, what will we start to have? And I mean, it can be anything, and it does not have to be futuristic. That was this thing about looking back to the past that Mario Carpo also says, for example, that now, for example, for dry stone walls, which are super irregular and difficult to model, but you can use AI because you could input images or 3D scans of that and start to build with this mode, ancient, super ancient, even archaic mode of construction. And I think this, for now, I just see a spectrum of possibilities that open, but there will surely be a few very original lines, and yeah, curious to see what it is. So some of the nice stuff I saw online had a lot to do with roughness, like with like these broken stones, this insertion into nature, and everything, because all these complex biological forms or natural forms you can work with AI. It does not make a difference. You know, if it's a square box or if it's something much more detail-rich.
Thanks, Pierre, for a really insightful presentation. My question probably goes in the same line, and based on what you presented today. Could you tell us, as someone working in Gen AI workflows in the AEC and architecture industry, is there something that you're really excited about and something that you are very fearful about?
Very good questions. The first one, the excitement, but I think now it's a bit this next frontier that everybody in the office, for example, say, okay, images are nice, it's an important tool, but the moment where we will be able to work with geometry, that will be the real moment. And I mean, the capability exists kind of out of the box, but you need like always, more control, precision, replicability. And I think you can harness these models, you can frame them into agentic workflows, and then you can bring in all the research from psychology of perception and representation of space and everything to start to see how much this model understands about space, which type of geometric errors they do they understand contiguity, do they have a sense of gravity, of whatever. So you can, like, peering into this model, like kind of PET scan or fMRI scanning their brains. I think super interesting. These world models as well. And the fear, that's a good question. The fear, it's maybe this, architectural slop built at scale. You know, if people start not to hire architects anymore because the clients, because they think, it's simple, I don't need an architect, I can do it all myself. Like, I mean, with images, we see that already. Clients would send you an image they made in Midjourney, and can you build that? So at the moment, construction is not solved by machines, but I mean, you see what happened with just pixels and text on the internet. No, there is a lot of garbage as well. And if you cannot close the lid of the laptop, but this is the build reality around us. This is a new, it's a space, like a Kohlhaas space, junk space 2.0, like, or whatever 0.0. That's a bit scary.
I can jump in. My question now turned into one question with two questions and two sides. Just to touch one on this opportunities that you were excited, right? And then you see it in the work you showed where you were zooming in. That's already a world model that exists, right? The world models that world labs want to do, right? They are mimicking reality as consistently as possible, but when you zoom into your painting, into your digital painting, then you start seeing new scenes and then a new scene and a new scene. That's, you know, plethora of worlds, this one, yes. So let's see how I phrase it in the most effective way. One is a challenge, right? To you, really curious what you think about it. If we can do any image that is perfect, the image has no value, right? It's just, these models have completely erased the value of an image to represent anything because anyone can do it. Because the value before in these visions were someone took time to express an idea, and by working on the way they visualize it, that's actually the value, that work. But then when you couple that, so image is no value, we are all rushing, I'm also doing that in our research, to even move to 3D, right? So suddenly then the whole kind of 3D modeling and reality construction, reconstruction will then maybe lose value, right? And when you couple that with the earlier digital paradigm that you showed in your initial slides, and even before that, when we were analog, architects always build our tools to design. And now we're in a position when we are not building the tools maybe, but we are given a tool by a huge company, a huge kind of consortium, extremely expensive to produce, and we need to start discovering maybe glitches or maybe these worlds there. So where is the value of what we will be doing, images or 3D or whatever?
Right, yes, thanks a lot. Actually, that was one of the main motivations also with Nova to start this exploration. First, like we were just playing around and then started to dig in a bit more. And that's really the idea that, okay, this technology is here, is powerful, it can be overwhelming, but let's just grab it and let's try to appropriate it for ourselves. And then the thing is that, well, first, when you get really familiar, it's a bit demystified. And also, you notice very quickly that two different persons do two very different things. And in many ways, it's super reminiscent from debates that already existed with photography, for example. Said, okay, that removes the craftsmanship from painting, and anybody can press a button. But well, now I think it's clear that you can have absolute fantastic photographers and that each person has a different eye. And I think that exists further in this technology. It's a bit more vertiginous because it's not just one world. It's many possible worlds. I mean, there are philosophers. It's called modal realism, the trend in philosophy that think they really exist just as much as our real world, and so some of the founding fathers of computer science were also convinced of that. And it's all a simulation, etc. So you might get lost, but yeah, the challenge is to find, with maybe curiosity, serendipity, what you're interested in, and that's very subjective and personal again. And I think that might be what remains also. I was thinking about this whole architecture thing. What does it mean when AI can do almost all of it? I remember the last office I worked in before Eitan Brechbuhl, Pascal Flammer. Pascal, he was saying that in a building he's interested in feeling the human behind the building, the architect. And I think that will still be there. For me, it's very strong in music. For example, you have quite good music, also slop, but some which are pretty convincing. But I mean, I'm still interested in thinking someone really played the guitar, really had that emotion, instead of 10,000 possible versions of it.
Yeah, the noise is just huge nowadays.
Right?
Okay. Anyone with a question that they want to ask now? Yes, great. Then there will have also be time at the after.
Hi. Just a quick question. There was a list that you at the
yes.
beginning
Yes.
with the architecture capabilities, let's say, and there was a percentage for each. Can you elaborate a little bit more about, is that your own estimation, or where does this come from?
Completely non-scientific, okay. Completely just in my own head, experience-based, but still, I think, relatively realistic. And it was just really to make this point, you know, that if you scan there, because we permanently have this debate also when I'm working at the office. Like some people say AI can do everything, some people say AI can do nothing, and then it's just about concretely looking. And it's not only AI, it's the rest of automation as well. And that was just to show it's a jagged frontier. There is also this idea in AI in general of a jagged frontier of capability. It's not like it's homogeneous, it can do everything 70% as good as a human, it can do things 5,000% as good as a human, and some things 30%, etc. And it's a bit here, I'm interested in the fact that there is this profile, and this is a painting, this is not data-based in any way. Thanks.
So when you show the benchmark at the end, and I see here constructive principles, 0%, we as a collective discipline, right? We should think, should we craft benchmarks that actually test models on this so that they can improve on that. Okay, I close it. Thank you, Pierre, once again. So you already mentioned, we mentioned a couple of times future of construction, so that's my next slide. We are really gearing up to a big event at the end of May, so it's rather soon. You can check the program, the different workshops available. We have a posters call, so please submit a poster for the symposium, and registration's already open. I'm happy to take any questions about that as well. And like you heard, among 11 extremely interesting workshops, also Pierre and Nittenbrecht will give one.
Also with Nora, she will also be here, and also
Nora.
Elia,
Yes.
who also does architectural visualization. We also have 2 external collaborators
Great.
on this one.
It's nice to have all these multi-sided inputs. And as we open today, this is a series, so Design++ seminar series. So the next talk will be end of March by artist and professor at ETH, Rosa Barba, and the chair of Art in Space and Time. So please join that. And now I invite you everyone to join the apéro, which is behind the transparent staircase over there. Thank you for being here in such a great weather with us.